Hello students, I welcome you all in this new session where we are going to discuss some questions on physics, and along with that we are going to build the concepts around those topics. Okay, so let me first tell you the name of this program, that is AIATS plus 2025 phase 2. Okay, phase 1 has already been completed and this is phase 2 which is ongoing. This test was mock test 4B and it was conducted on 9th of Feb 2025. Alright. So these are the topics which we are going to discuss. The first chapter is electric charges and fields. Second one is electrostatic potential and capacitance. Third one is units and measurements. Fourth one is motion in a plane and mechanical properties of fluids. As you can see, these two chapters are from your 12th class and the other three chapters are from your 11th class. Alright. Let's move to the questions then. This is the first question on your screen and this says a vector OA vector where O is origin is represented as OA vector is equal to 3i cap plus 3j cap. If the vector is rotated by 45 degree in clockwise direction, the new vector is represented as. Okay, so before solving this question, let's see the concept behind this question. Okay, so let's say there is a general vector, that is a vector. Let's say this is ax I cap plus a y j cap. Since the question is asking about a vector in 2D plane, that's why I am taking a general vector which is in 2D plane. Okay, so there are two components of this vector. One is ax and other one is ay. One is in x direction, other one is in y direction. All right. How can I calculate the magnitude of this force or this vector, that is mod of a vector? You know the formula already. The magnitude of this vector can be given as ax square plus a y square. This is the magnitude of this vector, a vector. Now, a vector has magnitude as well as direction, right? So I have given you the formula of the magnitude, right? But what about the direction? So we have to find the direction also. Let's see the direction of this vector with horizontal axis or the x-axis. So if I draw my coordinate axis, that is x and y axis, and let's say this vector is represented like this from the origin and this is a vector. All right. The angle with x-axis is this theta. Now to find the magnitude or the value of this theta, I can draw a perpendicular from this vector on the x-axis, right? What is this length? This length is ax, obviously, because the representation of this vector is such that the component is in x direction is given as ax, right? And the component in the y direction is given as ay, right? So this is ax and this is ay. All right. And this is magnitude of a, the length of this vector. Now tan theta is equal to, from the figure you can easily find out, this is ay and this is ax. So in this triangle, to find out the value of tan theta, I can write ay by ax. Okay. So now we know the direction as well as the magnitude. All right. So I know the how I can deal with this vector now, right? Let's go to our question then. A vector OA is represented as this if the vector is rotated by 45 degree in clockwise direction. The new vector is represented as. So I am making this vector here on this xy axis. This is O, this is A, this is OA vector. All right. Now let's find out. We have to rotate this vector by 45 degree in clockwise direction. But first I have to know what is the direction of this vector with respect to x-axis, right? So first let's find out this angle theta. Again, we know the drill, right? So tan theta is equal to ay by ax, right? What is ay? This is equal to 3. What is ax? This is also equal to 3. So this is equal to 1. Now tan theta is equal to 1 for which vector? For which angle? This will give me theta is equal to 45 degree, right? So this angle is 45 degree. Now we know the angle. Now notice that if I rotate this vector in clockwise direction like this, so I can rotate the angle, rotate this vector, and the angle of this vector or the direction of this vector will change. But what about the magnitude? Will it change? Yes or no? The magnitude of this vector will not change, right? So if this is the length of this vector, this will remain exactly same after rotating this vector by 45 degree. So first let's find out the magnitude of this vector. What is the magnitude of this vector? Again, we know the formula, right? This will be ax square plus ay square, right? What is the value of ax? That is 3. So this will become 3 square. What is the value of ay? Again 3. So this will become 3 square. Now we can write it as 3 square into 2, right? We can take out 3 from this root. This will become 3 root 2. So we know the magnitude of this vector now, that is 3 root 2. Okay, so we know the magnitude. Now I want to know the direction of this final vector, after rotating this vector by 45 degree. So if I rotate this vector in clockwise direction by 45 degree, what will be its orientation? Can you tell me? It will be along x-axis, right? It will be along x-axis. So this vector, this final vector, let's say this final vector is b vector, this will align like this. All right. Now b vector can be represented as OA vector, or the magnitude of b vector. Let me write it as first magnitude of b vector, then the direction of b vector, that is b cap. All right. B vector is equal to mod of b vector. Now mod of b vector is equal to mod of OA vector now, because the magnitude is not changing, right? So this will be equal to 3 root 2. Now what about the direction? So the direction is along x-axis. All right. The unit vector in the x direction is I cap. This is our final answer. Okay. So the final answer is b vector, or the new vector, will be equal to 3 root 2 I cap. This is the answer. Option 1 is the correct answer. Okay. Just by observation, you can eliminate these two options. Which one? 3 root 3 j cap and 3 j cap, right? Why? Because the direction of these vectors is along y direction, and the answer cannot be in y direction. It should be in x direction, right? But after finding the magnitude of that vector, we know that the option 1 is correct. Okay. Now I want to ask you one other question in this. Okay. So if the question would have been that the vector is rotated by 45 degree in anti-clockwise direction, then what will happen? What will be the final answer? Tell me. The magnitude will remain same, only the direction is changing. So the final answer would be, okay, this angle is rotated by 45 degree in anti-clockwise direction. What would be the answer? The answer would be 3 root 2, and the vector would be in y direction, right? So this will become 3 root 2 j cap. This would be the answer if I change the question and rotate it in anti-clockwise direction. Any problem so far? Okay. Have you understood this concept clearly? So if you get this kind of questions in your exam, then you will be able to deal with them, right? Okay. So let's move to another question then. So the second question is this: two particles are moving in circular paths of same radii with angular speeds 2 radian per second and 4 radian per second. The ratio of their centripetal accelerations is. What is the name of this chapter from which this question belongs? Right? Which one is this? This is motion in a plane, right? This is motion in a plane, or 2D motion. Okay, so this is this chapter, right? Now, as you can see, the particles are moving in circular paths. Their radii are same, but the angular speeds are different, and this is given as angular speeds as 2 radian per second and 4 radian per second. We have to find the centripetal acceleration. Okay. Before dealing with this question, let me tell you something about circular motion. So there are two types of circular motion. One is uniform circular motion. What is the name of the other circular motion? That is non-uniform circular motion, right? There are two types of circular motion. One is uniform and the other one is non-uniform circular motion. Okay. But in this type of circular motions, we need two kinds of acceleration. So let's discuss the accelerations now. Acceleration is of two types. Acceleration is of two types. One is centripetal and the other one is tangential. Okay. This centripetal has two more names. One is radial acceleration and normal acceleration. Okay. So centripetal, radial and normal, these are the same accelerations. The other one is tangential acceleration. Now, why there are two types of accelerations? One is centripetal and the other one is tangential. Why? Because acceleration is rate of change of velocity, and velocity has two things. Because it's a vector, therefore it has two things. One is its magnitude, or the magnitude of velocity is also known as speed, right? And the other one is its direction. So if any acceleration which is changing the direction of the velocity, then that acceleration would be centripetal acceleration. So this is change in direction. This causes change in direction. What about the other vector or the other tangential acceleration? This creates change in speed. Okay. So there are two types of acceleration. One is responsible for changing in direction and other is responsible for change in speed. Okay. So there are two types of acceleration. Now, uniform and non-uniform circular motion. What happens in uniform circular motion? Now you tell me. What happens in uniform circular motion? This is radius r, this is speed v. In uniform circular motion, speed remains constant. Now, if the speed is remaining constant, then what kind of acceleration would be there? What kind of acceleration would be there? Will there be centripetal acceleration? Obviously, there will be centripetal acceleration because the direction is changing continuously, right? So I can say AC is non-zero, obviously. What about the tangential acceleration? But since V or the speed is constant, therefore tangential part will be zero. So AT will be zero. Okay, AT will be zero. Right? So AC will be non-zero and AT will be zero. You should know this about uniform circular motion. Okay. Centripetal acceleration is non-zero, tangential acceleration is zero, and the speed remains constant, but the velocity keeps on changing, and that's why there should be an acceleration which is centripetal acceleration. Okay. What about the non-uniform circular motion? What happens in non-uniform circular motion? So in non-uniform circular motion, this V or the speed keeps changing. And if this is changing, then AT should be non-zero. What about the centripetal acceleration? Centripetal acceleration is again non-zero in non-uniform circular motion, because in non-uniform circular motion also the direction is continuously changing. Okay. So AC is non-zero and AT is also non-zero. Are you getting this this differentiation in uniform circular motion and non-uniform circular motion? All right. So this is the difference in these two types of circular motions. Now let's see some more formula. We know V is equal to R omega. Hai? This we can use in circular motion. V is equal to R omega. V is speed, R is radius vector, and omega is angular speed, right? Because we are going to use angular speed in solving our question. So you should know what is omega. Now this omega, where can we draw this omega in this circular motion? So if this particle is moving like this is radius vector r or radius r, then using right hand thumb rule, just rotate your fingers in the direction of this motion, okay, in the direction of this velocity or in the direction of this motion, and you will get the direction of omega with your thumb. So omega is in this direction, we show it in this direction, but it is coming out, okay. So these are the three vectors. This is v velocity vector, this is radius vector r, and this is omega vector which is coming out to the board, okay. So this is v equal to r omega. Now centripetal acceleration, which we are going to use in our question also. So AC is equal to v square by r. We know the formula already. This is v square by r. This can also be written as r omega square. Also, I can write this r omega square as r omega into omega, right? Now, what is r omega? We can write r omega as v. So this will become v into omega, okay? So if there is no radius given to you, but if you know the speed and you know the angular speed, then also you can find centripetal acceleration, okay? So there are three forms of this centripetal acceleration. V and r is given, then you can find this with the help of this formula or with these terms. If you know r and omega, then you can find centripetal acceleration with this form, and if you know angular speed and normal speed, right, or the linear speed, then you can find the centripetal acceleration like this. Now let's go to our question. We will solve this question with the help of whatever we have studied so far, okay. So two particles are moving in circular paths of same radii. It means there are two particles and their radius is exactly same. So r1 and r2, but r1 is equal to r2. With angular speeds 2 radian per second and 4 radian per second, let's take omega as 2 radian per second and omega 2 as 4 radian per second, right? The ratio of their centripetal accelerations is centripetal acceleration. So let's say AC1, this is centripetal acceleration of first particle. AC2, this is centripetal acceleration of the second particle, okay. What is the formula which we should use here? This is in terms, this should be in terms of r and omega, right? So this will become r1 omega 1 square, and this would be r2 omega 2 square, okay. R1 and R2 is same, so they will get cancelled out, omega 1 and omega 2. So this will become 2 by 4, and there is a square also, so this will be square. This is 1 by 2 chi square, and the answer would be 1 by 4. Do we have this kind of option? Yes, the first option says that the answer should be 1:4, and we have already calculated that the ratio of these accelerations should be equal to 1 by 4. Alright, so option 1 is correct. Okay, so I have taught you uniform circular motion and uniform circular motion, and with the help of these concepts we have solved this question. Any doubt so far? You can tell me. No? Shall we move to the next question then? Okay, so the next question says a particle has initial velocity 2 I cap plus 3 j cap and acceleration as I cap plus j cap. The magnitude of velocity after 10 seconds will be. Again, this question involves some knowledge of vectors, as well as this question is from motion in one plane, right? Initial velocity is given to me. Let's assume this as u vector. This is 2 I cap plus 3 j cap, right? And the acceleration is given as I cap plus j cap. Just notice that there is no units given. So initial velocity is given as 2 I cap plus 3 j cap. No unit is there. Acceleration is given as I cap plus j cap. No unit is there. Okay. Now I have to find the velocity after 10 seconds. What would be the final velocity? So u is given, acceleration is also given. Which formula should I use to find out the velocity, the final velocity? Yes, you know this. Tell me what should be the formula which I should use here. Okay, first tell me, is this motion is uniform motion or non-uniform motion? Is this motion is a uniform motion or a non-uniform motion? Obviously, it's a non-uniform motion because there is acceleration. Okay, since there is acceleration, so the motion cannot be a uniform motion. This motion is non-uniform motion, right? But the acceleration is constant, And if the acceleration is constant, then I can use the equations of motion here. So what are the equations of motion? The first equation is V equal to U plus A T. I am writing these equations in vector form now. Okay, so V equal to U plus AT. V is a vector, U is a vector, acceleration is obviously a vector, and T is time. Time is a scalar, right? So V equal to U plus AT. What are the other equations? The other equation is S is equal to UT, where U is a vector, plus half A T square, right? So S is equal to UT plus half A T square. U is again vector, acceleration is again vector. This is displacement vector, all right? So S is equal to UT plus half A T square. The third equation, 2AS is equal to V square minus U square. Now you see, these are two vectors. So this equation is in vector form, but these are coming in V square minus U square, right? So you can see these are coming in scalars. I can write these two terms in vector also. This should be written as V vector dot V vector minus U vector dot U vector. Okay, we don't need this equation right now, but I have shown you that there are these two more equations which are in vector form, which we can use if the question requires. Okay, right now I am going to use this equation only. All right, so V equal to U plus AT. V vector is equal to, what is U vector? U vector is 2I cap plus 3j cap. All right, plus what is acceleration vector? This is I cap plus j cap into what is time? This t is time, right? So we have to find the final velocity after 10 seconds. So I am multiplying this with 10. So this will become 2I cap plus 3j cap plus 10I cap plus 10j cap. Okay, so the final velocity will become, see, 2 plus 10, that will be 12I cap, and 3 plus 10, that will be 13j cap. So the final velocity would be 12I cap plus 13j cap, right? Now, this is the final velocity vector, but as you can see in the question, we are asked about the magnitude of velocity after 10 seconds. So I have to calculate the velocity in final velocity and its magnitude also. So this is the velocity vector. How can we find the magnitude of this velocity? That would be equal to 12 square plus 13 square. What is 12 square? It would be equal to 144 plus 169. After solving, this will become 313. Since the units were not given, therefore I am writing this as under root 313 units, not as meter per second or centimeter per second. Is it clear to you? Okay, so the answer is under root 313 units. So this question belongs to motion in a plane, and since there were vectors, so I have to deal these equations in their vector form, then only I will be able to find this or I will be able to solve this question. Any doubt so far? Any doubt so far? You can comment me. Yes, you can put your doubt in the comment. No comment so far? No doubt so far? All right then. Let's move to another question. During a projectile motion, again a question from 2D. Okay, projectile motion, but you know projectile motion very well. So during a projectile motion, if the maximum height equals the horizontal range, then angle of projection with horizontal is. Now, notice that the angle of projection is asked from horizontal direction, but sometimes to confuse you or to get to check your presence of mind, the examiner or the question may ask angle from the horizontal vertical direction as well. Okay, so whenever this kind of questions is asked, always try to carefully observe that question from where the direction has been asked. So the direction has been asked from horizontal direction only or the with x-axis only. Okay, so we will solve this, but before solving this, let's see the concept of projectile motion. Okay, so this is the trajectory of projectile motion. This is x-axis, this is y-axis. The trajectory of projectile motion is parabolic, right? And this is initial velocity of projection. This is angle of projection with horizontal theta. If this is u, then the velocity in horizontal direction will become u cos theta. The velocity in vertical direction will become u sin theta. We know this already, right? The acceleration due to gravity is in negative direction, minus, ay is equal to minus g. Okay, what is the acceleration in horizontal direction? What is the acceleration in horizontal direction? Ax is equal to 0. And if there is no acceleration in any direction, then what would happen? There will be no change in velocity, right? That's why in projectile motion, the horizontal component of velocity remains constant. So this will remain constant everywhere. Wherever you see, this will remain constant. But since there is acceleration in y direction, as you can see, g in negative direction, that's why is velocity in y direction will keep on changing continuously. And that's why you see that at the highest point, there is only velocity in horizontal direction, there is no velocity in y direction. Okay. Now again, when this object or this projectile will strike the ground, then the velocity, the magnitude of the velocity will become same as initial, that is u. This angle is theta, so this angle is also theta. Why I am writing this as theta? Because we know that this motion is symmetric actually. That's why if this is theta, this will become theta, and if this is theta, then this will be theta, equal to theta, right? If this is u, again this would be u cos theta, and this will become u sin theta. Can you notice that u cos theta remains exactly same everywhere? So horizontal component is constant, but the vertical component is changing continuously. And since the initial velocity was in is in vertical direction, and in the positive direction, the final velocity in y direction is in negative direction, but the magnitude is exactly same, that is u sin theta. Okay. Now, what is the range here? This is equal to r. The distance covered in the horizontal direction is called range. So this is r. This is maximum height h. What are the formula of this r and h? R is u square sine square or sine 2 theta by g. What about h? H is u square sine square theta by 2g. What about total time of flight or time of flight? That is t equal to 2u sine theta by g. Now we require this formula and this formula only. Okay. And dear students, to solve questions based on projectile motion, you should know all these formulas on your tips. Okay, so that you can solve these questions without wasting much time. All right. So r is equal to u square sine 2 theta by g, and h is equal to u square sine square theta by 2g. Right. Now the question says, during a projectile motion, if the maximum height equals the horizontal range, then angle of projection with horizontal is. Okay, so we are given r is equal to h now. So if r is equal to h, what is the formula of r? That is u square sine 2 theta by g. What about h? This is u square sine square theta by 2g. Right. Now I have to solve this. U square and u square will get cancelled out, g and g will get cancelled out, but this is sine 2 theta here. What is the formula of sine 2 theta? Can somebody tell me what is the formula of sine 2 theta? Sine 2 theta is equal to 2 sine theta cos theta. There are other formulas also, okay, so I am telling you other formulas too, so that you can remember and use them wherever required. So the other formula is sine square theta plus cos square theta is equal to 1. This is one formula, this is second formula. There is another formula. So if there is sine 2 theta, then we should know what is cos 2 theta equal to. So cos 2 theta equal to cos square theta minus sine square theta. Cos square theta minus sine square theta. I can also write this formula in terms of cos square theta only or in terms of sine square theta only. how can I write this formula in terms of cos square theta only? I can eliminate this sin square theta, right, with the help of which equation? This equation. Sin square theta plus cos square theta is equal to 1. Sin square theta can be written as 1 minus cos square theta. So this will become cos 2 theta equal to cos square theta minus sin square theta can be written as 1 minus cos square theta. So cos square theta minus 1, and this minus and minus will become plus. So this will be 2 cos square theta minus 1. In terms of theta or cos square theta, you can see the formula here. Now I want to write this in terms of sin square theta only. How can I do that? Cos 2 theta is equal to, again, cos square theta can be written as 1 minus sin square theta, and minus sin square theta is already here. This will become 1 minus 2 sin square theta. Okay. So this, there you can see that cos 2 theta can have three forms. One is cos square theta minus sin square theta. The other one is cos 2 theta is equal to 2 cos square theta minus 1. And the third one is cos 2 theta is equal to 1 minus 2 sin square theta. Alright. Now I have to use this equation only. Sin 2 theta is equal to 2 sin theta and cos theta. U square cancelled out. G and G will get cancelled out. Sin 2 theta can be written as 2 sin theta cos theta is equal to sin square theta can be written as sin theta into sin theta, right, divided by 2. This sin theta and sin theta will get cancelled out. Sin theta by cos theta will become tan theta. So this is tan theta, and 2 into 2 will become 4. Now, is there any standard angle which we know is equal to tan, of which tan theta is equal to 4? So we know tan 0, that is equal to 0. We know tan 30, that is equal to 1 by root 3. We know tan 45, that is equal to 1. Tan 60, that is equal to root 3. And tan 90, that is equal to infinity, right, or a very large number. But tan theta is equal to 4. We don't know. That's why we have to write the final answer in terms of tan theta is equal to tan inverse of 4, right? This will become our final answer. Can you see this answer in any option? Yes, the second option is correct, that is tan inverse 4. Now, I would like to ask you, is there any other way to solve this problem? Okay, so we have used the formula of range here, we have used the formula of height here to solve this, and you can see that we took so much time to solve this one. But there is another formula with the help of which we can solve this equation in just a single line. Can someone tell me which one is that formula? Yeah, steady empire, exactly. Okay, so there is a formula which can relate R and H with theta. Okay, and that formula is R is equal to 4H cot theta. Okay, you should know this formula. This is R is equal to 4H cot theta. Now, we are given that R is equal to H, right? So I put R is equal to H in this formula, and this will become H is equal to 4H cot theta. H and H will get cancelled out. This will become, this is cot theta, right? So cot theta can be written as 1 by tan theta. So this will become tan theta is equal to 4. And the answer would be theta is equal to tan inverse 4. Okay. So I have shown you two methods. Whichever method is remembered by you very well, or the formula which you can recall easily, can be used to solve this kind of questions. Any problem so far? So we have seen projectile motion or the concept of projectile motion with the help of this question. Okay. Let's move to another question then. This is the question. A solid body floating in water has 2/3 of its volume immersed in it. The density of the material of the object is nearly. Okay, so the chapter is mechanical properties of fluid. Mechanical properties of fluids. This is the chapter in which we study this concept. But what is the name of that concept? Somebody tell me what is the name of that concept which we can use here to solve this? This is based on Archimedes' principle. What? Archimedes' principle. Okay. the formula which we can get here from with the help of this Archimedes principle is FB is equal to rho VG. What is this FB? This is buoyant force. This is buoyant force. And what is buoyant force? Net force applied by fluid on object immersed in it, right? This is buoyant force. What is rho here? This is rho L actually. This is density of liquid, not the density of object. Okay, so if I ask you a question that whether the buoyant force depends on the density of the object, so the answer should be no. Actually, it depends on the density of the liquid, not on the density of the object. What is this V? This is VD. This is VD. Okay, so this is the volume displaced. Volume displaced by whom? By the object of the liquid. Not, this is not the volume of the object. Okay, this is the volume displaced by the solid of the liquid. G is obviously acceleration due to gravity. You know that, right? This is acceleration due to gravity. So these are the three terms on which buoyant force depends. Now, I have to use this formula to solve this question. So this is the solid body which is floating in water and which has 2/3 of its volume immersed in it. We have to find the density of the material. Okay. Now let's make the figure of this problem. So this is the water which is filled in this container, and this is the object. Let's say this is the object which is floating in it. Okay. Let the volume of the object is V naught, and the density of the object is rho naught. Okay. Now 2/3 of the volume is immersed, so 2/3 of the volume is inside the water. What about the other part, or the part which is out of the water? That the volume is V naught by 3. 2 V naught by 3 is inside the water and V naught by 3 is outside the water. Okay. Can you tell me which are the two forces acting on this object? This object is in equilibrium, right? So all the forces which are acting on it should cancel out each other. So what are the forces which are acting on this object right now? As you can see, obviously mg has to act, so mg is acting downwards and buoyant force is acting upwards. Fb is acting upwards. The system is in equilibrium, and since the system is in equilibrium, Fb is equal to mg. Do we know the formula of Fb? Yes, we already know the formula of Fb, that is equal to rho of liquid into volume displaced into g. However, I can write m here. So I have already taken the volume of the object as V naught and the density of the object is rho naught. So what would be the this mass of this object? That would become density of the object, volume of the object, right, into g. Okay. Now, what about the density of the liquid? So density of the liquid, here the liquid is water. So the density of the water is standard data. You should remember that is equal to 1000 kg per, cancelled out. This is gram per cc into volume displaced. This is the volume displaced now. So this is equal to 2 V naught by 3 is equal to rho of object. This V naught and V naught will get again cancelled out. So I am not writing, or I can write here and this will get cancelled out. Okay. So density of the object is equal to 2 by 3 gram per cc. Okay, this is the answer. Can you see any answer in these options? So 2 by 3 is equal to 0.67, right? So the answer, the option 3 will be our answer, 0.67 gram per cc. Okay, any doubt in this question? So now you know what is the formula of buoyant force. It was derived with the help of Archimedes principle. We have already drawn the FBD of this problem, right? So FBD of this problem should be clear to you. There were two forces which were acting on this, and since the object was floating, it means it was in equilibrium. That's why both the forces were cancelling each other, and with the help of that I have found out the value of density of the object. Okay, any problem in this? Any doubt so far? No? Let's move to another question then. This is the next excuse me, this is the next question that says which of the following has the least number of significant figures. Okay, first tell me the number of significant figures in the first data. Yes, how many significant numbers or figures are there in the first data? Anyone? Okay, so before solving this question, let's see the rules for the significant figures. Okay, the first one is all non-zero digits are significant, right? So if a number is like this, that the number is 1, 3, 5, 7, all these numbers are non-zero, right? That's why all the numbers are non-zero, that's why all the digits are significant. What about the second rule? The second rule says zeros between non-zero digits are significant. Okay, so if I write one number as 13057, since this 0 is between two non-zero numbers, that's why this 0 will be significant. Okay, so students are giving me the answers. Okay, students, right, the answer is 3. Okay, let's see. So let's revise this rules first, then we will try to solve that question. All right, so this is the second rule. What about the third rule? The third rule says leading zeros are always insignificant. Okay, so there are two rules with regards to 0 here. One is zeros between non-zero digits are significant, and the other rule which we have studied so far is leading zeros are always insignificant. What do you mean by leading zeros? So if a number is like this 0.001, these zeros are leading zeros. Okay, zeros before the first non-zero number are leading zeros. All right, so this leading zeros are always insignificant. Okay, fourth rule is trailing zeros are insignificant if the number doesn't contain decimal. If there is no decimal in the number, then the trailing zeros in that number would be insignificant. Okay, let's take an example of that. So if I write 1000, there are 3 zeros. These are trailing zeros. Excuse me. Obviously, these are trailing zeros. Does this number contain any decimal? No, there is no decimal. That's why these zeros are insignificant. That's why this number has only one significant figure. But let's take this number 1.000. Now this number contains decimal, right? And these zeros are leading zeros or the trailing zeros. They are trailing zeros here, right? So if they are trailing zeros and this number contains decimal, these zeros will become significant. Okay, so the other rule is, what was the number of that rule? So this is fourth one, this is fifth one. Trailing zeros in a number which contain decimal become significant. Okay, this is the last rule with regards to 0. Now the sixth rule is power of 10 in a number are insignificant. Okay, this is insignificant. Now we know all the rules which we are going to use to solve this question. Now tell me the number of significant figures in this first one. How many numbers are there, or how many significant figures are there? Will this be significant? No. Power of 10 will not be significant. Okay, so this number contain 3 numbers which are non-zero, that's why these all are significant figures. How many significant figures are there in the second number? Anybody tell me? How many significant figures are there in the second number? So these zeros are leading zeros, right? And leading zeros are always insignificant. That's why this has only one significant figure. What about the third one? 7.3420. This 0 is trailing 0, but this number also contains this decimal. That's why this 0 will become significant, obviously. So 4 and plus 1, 5 significant figures. What about the last one? 3.021. This number also has 0, but this 0 is between two non-zero digits. That's why this will become significant, and the number of significant figures will become 4. Okay, so what should be the answer? We are asked about least number of significant figures, and number 2, that is 0.003, contain only one significant figure. That should be our correct answer. That should be our correct answer. Okay, so any confusion in these rules? Anybody? Is it clear now? Is it clear? Okay, so if you don't have any kind of query in this problem, then let's move to another. Question number 17. Question number 17. Number of electrons which would transfer from one body to other to develop -8 coulomb of charges. Okay. Now, as you can see, electrons are getting transferred from one body to another, and there is -8 coulomb of charge. Okay. So let's say there are two bodies. This is body A and this is body B. Both are neutral initially. Okay. Both are neutral initially. Now, if I take some electrons from this and transfer to this body, then what would happen? Both the bodies will be charged, right? Since it has less number of electrons now, this will be negatively charged or positively charged. This will be positively charged, obviously. And this has more electrons than before, that's why this will become negatively charged, right? So this is positively charged and this is negatively charged. Okay. So students, as you can see here, usually we share electrons from one body to another to charge the body, right? Because positive charge resides inside the nucleus, right? And it is very hard to take out charge from the nucleus. That's why whenever you see the questions of charging and discharging, you will notice that always charge which is getting transferred is through the electron only. Okay. So this will be positively charged, this will be negatively charged. Okay. Now, which equation which we are going to use in this? Tell me the name of the equation or the properties of the charge which we can use to solve this kind of question. This is Q is equal to NE. Okay, and this equation is from quantization of charge. Okay, this is from quantization of charge. Q is equal to NE. Q is 8 coulomb, so I am writing 8 here. N, I have to find out the number of electrons, and E, charge on one electron. That is equal to 1.6 into 10 raised to power minus 19 coulomb, right? I am dropping minus here and minus from here. So 8 is equal to N into 1.6 into 10 raised to power minus 19. Can we solve it? Yes. N is equal to 8 divided by 1.6 into 10 raised to power minus 19. This will become 8 into 10 raised to power 19, right? Divided by 1.6. Okay. I am taking out this decimal, so it will become 10 here. Now this 8, this will become 2, 2, 5. This will become 5 into 10 raised to power 19. This is the number of electrons which you will need to transfer from one body to another to charge any body with this. है ना, with -8 coulomb. Do we have this answer? Yes, this is option 1. Excuse me. This is option 1. So 5 into 10 raised to power 19 is the correct answer. Okay. Let's move to another question now. This question says, a metallic sphere of radius r have charge q distributed over its surface. The electric potential at the surface of a sphere is, and k is equal to 1 upon 4 pi epsilon naught. Okay. Now see here, this is metallic sphere. This is metallic sphere. Okay. This sphere can be a spherical shell or it can be solid sphere. As long as this sphere is metallic, now this both the spheres, solid sphere as well as spherical shell, will have exactly same kind of potential and electric field for them. Okay, so the charge would be distributed over their surface uniformly, and spherical shell and solid sphere will have exactly same kind of potential. Right now, we have to talk about the electric potential at the surface of this sphere. Let's say this is the sphere, this is the charge q on the surface, and the radius is given as small r. Okay. Now tell me, what is the potential at any point? Okay, I am taking this distance as d from the center, any point p outside the sphere, that we can write as k q by d, right? Kq by r, kq by d. What about the potential at its surface? That would be equal to V equal to K Q D will become equal to R. So this is D greater than R. This is for D equal to R. What happens when we take this point inside the sphere? So if D is less than R, can we write KQ by D, or the formula changes here? Someone give me the answer. What should be the potential inside the surface? That would be equal to KQ by R. It becomes same as the potential at the surface. Okay, since the electric field is non-zero outside but zero inside, that's why the potential from the surface and inside the metallic sphere does not change, because there is no electric field to change the potential, right? That's why the potential inside this sphere will become constant, and that would be equal to KQ by R, the surface which is at potential, the potential which is at its surface will remain same inside it also. Okay. Now what is the answer here? We are asked about the potential at its surface, so the answer would be KQ by R, this second option. Okay. Any doubt here? Any doubt? So we are asked about the metallic sphere, but what if the sphere is non-metallic? What if the sphere is non-metallic and it is uniformly charged? Okay, uniformly charged with volume Q, with charge Q. Okay, so this is like this. This has material everywhere, and that's why this has charge everywhere. And let's say its radius is capital R and the charge is Q. What about the electric field? So electric field is KQ by R square. Here R is the distance of any point P from its center. Okay, so R is greater than capital R, E equal to KQ by R square outside. What about it? The electric field at its surface, it will become KQ by R square for R equal to capital R. Now what about the electric field inside it? Will it become 0 now? It was 0 for the metallic surface, but will it be 0 inside this non-metallic sphere too? Anyone? No, it will not be 0. It will become KQR by RQ for R less than capital R. Okay, since there is no zero electric field inside the metallic sphere, therefore its potential also changes inside the sphere. Okay, and that formula become KQ by 2r cube 3r square minus 3 capital R square minus small r square. Actually, you can verify this formula by putting small r equal to capital R. So if I put small r as capital R, this will become 2r square, right? This 2 and 2 will get cancelled out. R square will get cancelled with this r cube. So we will left with k cube by r. That is the potential at the surface. Okay. So V is equal to k cube by small r. This is for r greater than capital R, and this formula is applicable for r less than capital R. Okay. So if this is the metallic sphere, then we can deal with this, and if the non-metallic sphere is given, then we can use this formula to solve. Okay students, so we are done with our session here, and I hope that you get to know so many things from this session, and okay, so revise all these concepts and we will meet in the next class. Thank you.